chambers and blood chambers. So this is a table to show the different kind of machine. You see the manufacturers made their own machine. Like you see what very popular now in Vietnam. We see this is a Prismalang from Buster. So this device is actually working for the CRT, and they add one function here for the CO2 removal. And I very appreciate the introduction of this kind of device in Vietnam because at the beginning, when I visit Europe, I saw the device, but from different company. So I talked to that guy and to bring to Vietnam, and because of some delay, so they cannot bring. And I think that Buster is the first one to brought this kind of machine to Vietnam, and now we have that available in several ICU in Vietnam. Another option you can see that the Hemolungs or Polung or ILA active in Novalungs. So the difference between the two of this group, you can see that based on the kind of filter surface areas. In this one, you can see from Buster, they have the surface area of 0.8 square meters. And gas sweep gas and blood flow and catheter size and like this. But on the other side, we talk about the high flow CO2 removal. And for example, Novalungs, you see that surface area higher. You see sweep gas, it's the same. You see the blood flow higher. And of course, when you use a higher blood flow, we need to use bigger or larger catheters. And when you want to increase the removal of the CO2, of course, there are two ways or combination of both. First, you can increase the surface areas, increase blood flows, and you can remove blood CO2. Like if you compare between the two different types, you see this larger, bigger can remove more, double of this level. But of course, you see the catheter like this or carinol like this, you need to have very special people to do the procedure. And that's why, of course, in a big center, you have no problem. But a very small center in many countries, you cannot do that very well. So this is a picture we took at our department, and thanks Dr. Tuan for the first guy. And I think that in the future, Dr. Tuan face all the way look in, you can see his face in here, and another nurse take care of the patient. You can see the face in here. And this is a standalone, like I mentioned earlier, only one single CO2 removal column. And the other side, you see the both, this Osiris membrane is for cytokines removal and CO2 removal on the left side. And of course, in this kind of device, they look very colorful. And of course, compared to their former device, I think this is most colorful and it's very attractive to work on this kind of machine. So why we need to remove CO2 in the ARDS patient? So long time ago, I don't think any problem with ARDS patient when we use a high volume ventilation. Like we use VT of 10 to 12 cc per kilo. In that case, you have nothing to worry about CO2. But when we reduce the tidal volume, and now we know the recommended is 6 cc per kilogram. In that case, a lot of airway will collapse, and a lot of when we do the balancing between the alveolar ventilation and dead space ventilation, if we reduce the VT dead space ventilation, the percentage going up. For example, a VT of 6, I think dead space ventilation already going up to 50%. usually it's less than 30%. So we not take into account of the lungs collapse. That space in ventilation all the way going up in the ARDS patient because of doctor reduce VT. So when we reduce VT, the oxygen course going down. If you have no PEEP, oxygen going down, CO2 going up. So that is the kind of consequences of the lungs protective protective lung strategy. So something like that. Nowadays we see more patients with a CO2 accumulation in the blood. So CO2 removal is the therapy to solve the problem causing by the doctor going too much of reduction in VT. And of course, in the many areas in which you do not have the CO2 removal technology, you have only one way when the CO2 level going up is to increase the VT. And of course, we already know very well when we increase the VT, the patient likely die than the patient with lower VT. So that's why in many recommendations, they recommend you to use lower tidal volumes, lower plateau pressure with the CO2 removal technology. And of course, in here we see that it's the best can recommended in case of the PF ratio of less than 200. And many recommendations even go deeper to 150. But of course, you can try when it's lower, like it's very severe ARS in here, like this. But you see in here, we have another option like ECMO, inhaled nitric oxide, or high frequency ventilation, or prone positioning. So this kind of technique or this kind of addition is very important for the ARDS patient. Okay, so why we use the COPD for COPD patient? COPD patient is easy to understand because the COPD patient is CO2 level all the way high. And of course, in the case of stable COPD, you see the pH level is in normal range. But in the exacerbation of the COPD, pH going down. So that's why, of course, when you put the patient on ventilation, mechanical ventilation and positive pressure ventilation, the CO2 removal can be either going up or going down. So if you do very well, you are a good doctor, you can going down because you're taking care of the patient very well. But in many cases, the doctor, when they put the invasive ventilation, the patient CO2 going up, and many doctors don't know how to do that. So in many cases, CO2 removal can be the good option for this kind of patient. However, of course, because the COPD patient already get used to the CO2 level high, so sometimes the technology may not make them feel very happy after they do something for the patient. So what indication for the echo removal device? And we see here is several indication for this at this moment they focus on. The first indication we see that is very clear in the kind of mechanism in which is control of hypercapnia and respiratory rate in COPD exacerbation. And the second is for ARDS patient or patient with they call that on-chart protective mechanical ventilation. And this kind of technology and this kind of philosophy very popular in Europe, but not popular in the US. So that's why, of course, nowadays CO2 removal is not a technology of choice in many countries in North America. Another indication is you can see in the asthma or the patient bridge to lung transplantation. And I hope this kind of patient will be more in the future when we can do lung transplantation more often in Vietnam. So what is the recommendation or what is expert meetings decision? So this guy a group of around more than 10 leading expert in Europe. And of course, in this group, they based on several good, very good, very popular expert, but also you can see some name like Kai Herensky. This guy working for Buster, so he also working for the research side of Buster. So there's some kind of recommendation within this group. Maybe can maybe not totally right if you don't have any interference from the manufacturer of the one product. So what is they recommend? Of course, this is not like what you must do because they based on the expert ideas and some recommendation based on the research. But you see in here, they don't based on the kind of recommendation from research, but they based on what the experts say or think about what is good for patient. So we see here in initiation criteria, you can see driving pressure. They very aggressive. They if the patient just driving pressure of the 14 and above, they already recommend to use technology or plateau pressure of the 25 and above. They recommend that. This is a consensus, and this a big agreement. Of course, when you do the ultra protective lung strategy, this is the criteria for that kind of for the patient. And majority agreement is here PCO2, pH, and reduction of the VT to less than 6, respiratory rate, etc. And basically, this kind of thing is a majority agreement. I mean, here they have 31. So if the 31 and 22, they call the consensus. But less than that, they call that majority agreement. So when we talk about the kind of consensus, you need to be very careful because sometimes it not represent all of the idea. And target treatment like that, then you should do put the drying pressure less than 14, battle pressure 25 and lowers, respiratory rate at 25 or 20. So even some case, they will aggressive to 20 or less than 20. And this kind of targets, I don't think it's easy for anyone to follow because it's too strict and too aggressive. And another recommend thing like target for initiation, rescue, target for initiation, on-child protective ventilation. Of course, they have some number for you to can try to remember. But basically, they even going lower than that. Like in this on-child protective, they go from 15 to 30. And for weaning, they also recommend something like this. You can see in here, but you can look later when you have time. For COPD, you see that very few consensus because of COPD patient also. Maybe in Europe, they don't have so many patients, or maybe they don't care much about, or maybe that no evidence or very few evidence. So we see something like COPD patient on non-invasive ventilation, but you don't see any improvement in CO2 removal from the machine. You think about that, okay, going to with the echo or something like this. And basically, it's not clear what is really clear cut or cut off for the PCO2, for respiratory rate, for pH, or from something else. And something like this is okay. They also target for parameter and target and also weaning, similar like in ARDS patient. They also recommend based on that criteria. So what about research in the echo? Here is the first one, I think, is We can see that in 2009, we see the group that show that how the technology working on the patient. And we see this is a start with the patient, ARS patient, and we start with lung strategy, protective strategy. And of course, when you reduce the blood pressure over the VT, you can see that CO2 level going up. And one patient going to very high like this, go up to 85 from around at the beginning already quite high. And of course, when you CO2 level going down, you see pH level going, CO2 level going up, pH level going down. And when we start to do the CO2 removal, we see immediately within 1 hour and a half, CO2 level going down and pH going up. This is to show that the technology working very well for the patient. And how about on the patient? And even when we reduce the kind of CO2 and reduce the airway pressure, you reduce the VT, what is the result for the lungs? And we very popular, we know about the ventilator lung injury or VLI. And VLI mean when you ventilate patient with the pressure, high positive pressure, you see that a lot of biomarkers or a lot of cytokines be released from the lungs. And this is a cytokine can see seen in the ARS patient, like interleukin-6, interleukin-1B, interleukin-8, interleukin R8. So this is a group of patients. We see the level of these markers. And when we use CO2 removal, we compare between the before and after. Like this, in this group, a specific group, of course, it's not so many patients, only 10. We see that can see the difference between before and after the CO2 removal. The level of interleukin-6, for example, in this case, going down. And that is mean when you relieve the stress from the lungs, the stress going down and inflammation process stop, and interleukin-6 is not going up anymore. And how about the compare between when you lower VT to even very small VT, like 3 cc per kilogram compared to 6 cc per kilogram? This study plan, you can see that patient is not so many. And we can see that the difference between the level of oxygenation in both groups, this group with the pH ratio of 100 and above, 150 and above, and this less than that, you see that the Kaplan-Meier curve can be differences in this side. So that means in patient with lower oxygenation, that means the lungs more collapse, or the patient should be protected of the lungs, we see more effectiveness. Another study to show how safety and how safe and how effective when we use the CO2 removal technology. And here they compare between the kind of conventional treatment, that means already protective lung strategy with ultra protective lung strategy. In this case, they reduce VT to 4 cc per kilogram and plateau pressure less than 25. And this group of 95 patients, and we see that the technology can working very well. Within 8 hours, already 78 patients got to target of CO2, and within 24 hours, of course, going 10 more, 4 more percent. And they look at the kind of side effect. This side effect only 2 patients. I mean, very small, and of course, very many patients discharged from hospital. But later on, when they think that, okay, it's time to compare in randomized control study, and this they compare between 200 patients with echo and 205 patients in lung protective strategy only, no difference in mortality. But you should focus in this kind of Kaplan-Meier curve. This upper part is echo, even mortality is higher than ventilation alone. So that's why when we look at that kind of talking about significant or non-significant, but remember when the number going up for the intervention group is always alarm for a doctor to take. Many doctor in many center they don't want to do some kind of technology if this kind like Kaplan-Meier curve show like this. However, for the many intensivists, control of the patient is very important, because if you do not do very well for the patient, sometimes you set the target and you cannot meet that. For example, the target the tidal volume, the target the beat, driving pressure, and sometimes the target is the respiratory rate. If you use only the mechanical ventilation and you cannot control very well. So in this kind of subgroup analysis of each parameters like this, you see that in the echo group, you see more chance of very well controlled than the conventional therapy. And recently, when we have more technology, high technology like electrical impedance tomography, you can even personalize the ecotherapy, like in this case. For example, in start with 6 cc per kilogram, in going 4 cc per kilogram, and you don't know what happened in the lungs. Because of when you're going down in the VT, of course, the lung will collapse. So usually when you going down in when lung collapse, you can do more by just increase the PEEP level. So you don't know how much you can increase PEEP level if you do not have any kind of measurement. So EIT can help you. For example, they see this, you just maintain the kind of ventilation on the EIT machine. It's quite okay for the patient. Another recently group of, from Europe tried to summarize and review all of the data from the CO2 removal, and they have quite a lot of study, almost 50 study in almost 1,700 patients, and they conclude that okay, CO2 removal is good because it reduces it can improve the acidosis and it can improve the symptoms. However, it cannot show benefit in mortality. Of course, it's not easy to do so in a lot of study in ICU. How about the CO2 removal in COPD patient? And this study, of course, you see that they have a control group of the quite small number, 25, and eco group is 26, and they successfully show that CO2 removal can improve the pH, PCO2, and almost 90% of patients avoided tracheal intubation. But of course, this patient is failed of the non-invasive ventilation. That means if you do not have echo, you have to intubate the patient. That's the study, I think, is doing very well to show that echo is very effective for the patient. And recently they have studied like this and already waiting for the result. And I hope that it have positive result for COPD patient. So in conclusion, CO2 removal is a method very effective in many ICU patients. And of course, it's safe because we use the low flow system, and a lot of the CRT machine can take care of that. However, we not have the not good result in many study, and most consensus is sometimes it not it is sometimes quite subjective. So that's why we still need to do more. We need to do research, and we need to try to apply and to be master in kind of technique. And of course, if we can do so, we can say whether it working or even it can save the patient. Thank you very much.
Thank you, Professor Sơn. You have a comprehensive presentation about the echo. I think the next talk, I would like invite Dr. Hồi present your talk. Today, Dr. we present his record for the case study. And Dr. Hồi, can you hear me?
I can hear you, but tonight I have to work at clinic, and sometimes the internet connection is unstable. So I'm sorry. I'm sorry about everyone. I have to record my presentation. Sorry. I am sorry about you because I am busy tonight. So I have to record my presentation before. Tonight, I show you about the topic echo for ARDS patient. As you know, ventilation with low VT is still considered the standard of care for patients with ARDS because it improves mortality. However, ventilation with low VT can cause undesirable respiratory acidosis. Therefore, some chest methods are needed to reduce CO2 while ensuring that patient is chest according to the above strategy. Below, we present a case of successful treatment of low VT ventilation, but still having respiratory acidosis chest with extracorporeal membrane CO2 removed. Extracorporeal carbon dioxide removed means ECCO2 support gas exchange in patients with the acute respiratory distress syndrome. During CO2, venous blood is drained from a central vein via cannula pump through a semi-permeable membrane that permits diffusion of carbon dioxide and return via a cannula to a central vein. ECCO2 yield low blood flow rate through a small cannula and provide substantial CO2 elimination from 20 to 70% of total CO2 production. And by with marginal improvement in oxygenation, the rationale for using ECO2 in ARDS is to facilitate lung protective ventilation by allowing a reduction of VT, respiratory rate, plateau pressure, driving pressure, and mechanic power delivered by the mechanical ventilation. And tonight I show you case study. The male patient, he is 40 years old. He has chest complaint, respiratory failure. He has a past medical history of chronic renal failure due to glomerular nephritis, received kidney transplant in 2017, and hypertension. The patient is using drug, Celsep, Medron, Betaloxoc, and Amlor. Patient have a fever and difficulty breathing at home. On 1st of August, patient had to admit to Vinmec Hospital and Chen Vietnam Hospital after patient were diagnosed with pneumonia and treated by antibiotics, concludes Meronam, linezolid, colistin, respiratory support with HFNC, anti-rejection drug, and CRT for time. But the respiratory did not improve. The fever persisted. Patients were intubated and transferred to Bạch Hospital. On 30 of August, at ICU, patient have sedation, mechanical ventilation via endotracheal tube, spout E150, blood pressure E160 and 100. Patient have a fever 38 degree. The SpO2 is 87%. It means low SpO2. The pulmonary mechanics of patient are compliant 23, P plateau is 28, and speed is 32. The chest X-ray show diffuser of bow lung. The test CMV and EBV, sputum and blood is positive. Bronchial fluid PCR show Pseudomonas aeruginosa positive. Patient were diagnosed AIDS complicated pneumonia, and treatment is sedation, mechanical ventilation according AIDS, ganciclovir antibiotics, and anti-rejection drug. But the result of arterial blood gas show respiratory acidosis. The pH is 7.2, and the PaCO2 is 76. While the oxygenation of patient is answer. The patient were using ECCO2 and CRT and were ventilated AIDS, the VT and the rest, and P plateau and dry pressure after degree after using ECCO2. When you see the figure, the after plus blood gas, the at the first is so respiratory acidosis. When we use ECO2 after 1 hour, the pH of ABG is normal, and the PaCO2 is normal. After that, the patient has no fever, and he was discontinued ECO2 after 72 hours. Then he was activated and discharged after. So the currently guideline I use for my presentation is consensus of a European roundtable meeting. Thank you for your listening.
Thank you, Dr. Hồi. And now you everywhere have some questions from the audience. I think now we have the many people in the group. Anyone have a question for two speakers? Now I think in my field we have one patient is undergoing doing echo in the patient in room number 603. I think we have many questions for two speakers. Dr. Hiền.
Yeah, thank you very much for your presentation. I have a question for the two speakers today. You see how effect of the eco removal change over the time is meaning is how long we could is more time we perform is how effective is it? I mean that. Yeah, thank you very much.
Okay, Dr. Hoi, you can go first. No, Dr. Hoi, you need to turn on the microphone.
So sorry, Dr. Chen. I can listen your question. You can repeat your question again because the internet connection is unstable.
My question is that is how effect of the ecosystem to how effect of removing the CO2 of the ecosystem is changed over the time. You got it. Is it after 1 hour? Is it and 2 hour? Is it less effective? I mean that, or is it the same? Is it 1 hour, 4 hours, or 24 hours? Yeah.
It some of studies. So when you AIDS, the PaCO2 can reduce moment. The sweep gap in when you use CO2 from about 10 liter per minute can remove the CO2 the target CO2.
Okay, thank you, Dr. Hoi. So you start with the answer, and it take very easy for me now because of course, Dr. Hiền can see that how it effective. Of course, when you see that the difference between the level of CO2 in the blood at the beginning is very high. So when you start uh, remove, of course, the difference delta is very important. So when you see the delta go, the more CO2 in the blood, you can remove more at the beginning. But later on, the removal, I think, still the same. However, because of the balance, the delta is going down. So when the delta going down, you cannot, you see the similar thing like a CRT. When you see that equilibrium between the two chambers, and at that time you cannot, it is the same level already, so we cannot going faster or something like that. And of course, you can increase the sweep gas to 10 or maximum. However, still you have nothing inside to remove. So that's why sometimes you need to look at another kind of way to remove the CO2. For example, in many cases, you can still remove CO2 by ventilation. So you cannot replace everything by the CO2 removal device. Instead, you use that like kind of backup in case the ventilation cannot remove very well. You can use the eco in that case to support to the mechanical ventilation. You can have the lungs of the patient rest more, or you can prevent trauma injury for that patient. So I think CO2 removal technology cannot replace everything, and it still need you to understand about how to remove the CO2 by the patient respiratory system or by the mechanical ventilation. Is that clear, or is that answer the question? I hope, Dr. Hian.
Yes, yeah. Okay, thank you very much.
Thank
Yes.
you, Dr. Ian. I think you have a difficult question. Okay. And Dr. Chang.
Okay, thank you for two speaker today. I also have some questions for Professor Sơn. The first question is I see in the initiation criteria in in the paper in guideline from European. Can you tell me how many criteria must be met to indicate for echo, and what the most important parameter that the clinician to pay attention more? The second question, can you tell me what are the differences between the echo and conventional CV VH characteristics? Is there anything difference in the outflow or return parts of two type character? Thank you.
Okay, thank you, Dr. Chang, for the question. I got the first question very well, but the second one I need you to repeat later on. But go ahead with the first one. I think that of course when you sit down on the kind of consensus meetings, they can just put on the list of what you think is important. For example, Dr. Chang can think maybe respiratory rate is important. Dr. Cường can think or maybe plateau pressure, or Dr. Hian may be thinking about driving pressure. So they start to vote. And they vote is the more number of the doctor think maybe respiratory rate more important than driving pressure. So you see the list, they always show that the consensus mean for the driving pressure. So many people believe that driving pressure is the most important criteria to start with the eco technology. However, you can make those by yourself. Like you think that the patient with driving pressure maybe now is 15. The recommendation they based in Europe committee is 14. But the mean you can start. However, we see respiratory rate patient now only 22 or 23. You see that maybe VT is around 6.5. So you see those patients actually you still have so many room to improve. Like you can going down in rate, you going down to VT and going up to rate, and that means those number, of course, it not it the absolute clear cut when you decide whether you can use eco or not. You need to base on the clinical practice, like Dr. Cường said about the case in the sixth floor. Actually, that case do not respond very well to eco, and he already moved to the ECMO device this morning. So something like that, because you guys always do not start with any criteria. And when I ask, oh, why you don't do this one for the echo for the patient? Every people get to do the echo for the patient. Of course, that patient in fail echo because it already too late. So it's the first question. So how about the second question?
Okay, thank you. My second question is can you tell me the differences between echo catheter and conventional like CVVH catheter? As we know, the catheter in echo and CVH we can call double lumen catheter. And can you tell me what the difference, the most difference thing between type of like echo and CVS at the out or in the lumen?
Yeah, that's a good question. I think that I'm not expert in the catheter, and later on I can ask Dr. Cường give more comments for the question from you. But basically, what we very I think we know very well because of when we're talking about the flow, we see the flow is the kind of you know the flow is actually it depends on so many factors like the size, like you talk about double lumens, the catheters. And you see that, of course, if you have the bigger catheters or larger, you know, the lumen, the internal lumen, you can see that the flow easy to get through the system like that. And of course, the distance between the in and out of the system is so very important. So you can try on the clinical practice, see which is better for the patient. But of course, when you're talking about the eco procedures, you're always thinking about something bigger because you cannot use a conventional or a conventional catheter for the CRT to for echo removal because the flow based of those catheters are very low. You go to 100 to 200. So I think 200 cannot remove anything. Of course, you remove something, but it's not effective in comparison to the you use the CO2 removal filter is go up to 0.8 square centimeters. In that case, no meaning to increase the size or the space area of the subspace or space areas. So things like that is always need to be doing some research in the laboratory before you try on the patient. So Dr. Cường, you can give some comment for that.
Yes, thank you, Dr. Sơn and Dr. Chang. I think because as we know in the echo, we use a bigger blood flow comparing CRT. Normally in CRT, we use a blood flow less than 200 ml per minute, but in the echo, we use greater than 300 ml per minute. So it's important the echo catheter we use a bigger size, and the second important when we in the CRT catheter we have many tip shape of catheter like double O, double D, or cycle C tip catheter, but in echo the Buster company produce a catheter with a shotgun tip. It means that there's a long distance of the in and out blood flow. So it makes when we perform echo the lower regulation syndrome, like when we perform VV-ECMO. So I think there are two big different thing in echo catheter and CRT catheter. The first, it can move. This can drain a bigger blood flow, and it's much less regulation syndrome in echo.
Thank you, both person and Dr. Cường. I have an idea. If in the situation we do not have a bigger karate, uh, um, is it possible to use an additional outflow path to connect with the echo karate to make the flow velocity higher, uh, and it's made to increase PCO2 excretion efficiency higher.
I think it involves the
It
tip of
mean
shape.
like to win like the same the VV.
Because in the echo catheter, there are two different comparing CRT catheter. The first is bigger, bigger size, and the second, the different of the tip shape of catheter. The tip shape of echo catheter is different in the CRT catheter. Now in Buster company have a catheter with the shotgun tip catheter, shotgun tip. So it makes less circulation prevalent in echo.
Yeah, okay, Dr. Chang, I understand.
Okay, thank you.
Dr. Chang, I understand what you mean. Of course, if you do like that, I think the best. You will give one side, you have the one vascular access and to to withdraw the blood, and another access you just pump back the blood back to the system. Of course, that it can be the best system, I can tell. However, if you look at the patient and you cannot do a lot of vascular access like that, and so that's why you need to use bigger catheters and only one side access. You can, of course, in case you have nothing, you have no special catheter like Dr. Kung mentioned earlier. You can try do. I think that's working very well. Like a VV ECMO, something like that.
I read a study. I read an article about that. The author used two catheter, one in the femoral vein and one in the arterial vein, to avoid the recursion femoral. But maybe in the actually maybe we I think we don't need to do it because the tip of catheter in echo.
Okay, thank you.
And Dr. Tuan, the first Vietnamese people perform echo in Vietnam.
Thank for Dr. Cường for introducing. But today I have no comment and have no question for the speaker today.
Okay. Anyone have question for Professor Sơn and Dr. Hội today? Dr. Huy? Okay. Okay, I think now 9:05 p.m. I think today we have a two interesting presentation. Dr. Sơn, Professor, have a good and very interesting presentation in echo in critical in ICU, and Dr. have a good case study about the echo. I think echo is one method for ARDS patient. It makes the patient reduce the feeling when the patient ventilate. I hope in the near future we can do more and more patients and have many experience about the echo. And now in our group we have Dr. Hoi and Dr. Dr. Chang in CRT group. I hope in the near future you can have our center do more and more patient and have a good study in our ICU. And I hope in the near future we come back the topic today and we have many questions for speaker. In the last, I would like to thank you, Professor Sơn and Dr. have a good presentation today, and thank you all of you join our club today.
Okay, thank you, Dr. Cương. Thank you, everybody. See you next time.
Good night, everyone.
Good night.
Bye.
Good night, everyone. See you later.